So we've learned a lot about functions, all different types of functions. We've learned about linear functions. You've probably learned about radical functions and quadratic functions. And we're going to introduce a new type of function, a couple new types of functions in this unit. But first we got to understand the idea of what a composite and an inverse function is. So let's explore a little bit here. So we got our function notation. F of x. So we read this as f of x, right? And so this means that x is going into the function, f is the name of the function, and this is what's going to happen to the x. So let's go ahead and put 5 in there. And we have 5 squared plus 3 times 5. It's a good idea to put parentheses around it there. We have 25 plus 15, which is 40. So the value of f of 5 is 40. When 5 goes in, 40 comes out. All right. Now, what about f of negative 5? Well, negative 5 squared plus 3 times 5. So negative 5 squared acts the same, 25. Oops, that's a negative. But we end up with negative 15 this time, so we get two different answers. We get 10 in this case, right? Well, can we put something like 3a in? Well, let's see what happens. So a variable just represents a number. So 3a is like, it could be 5, it could be 6, it could be lots of numbers because we don't know what a is. But we can still substitute the same way because the function says we have blank squared plus 3 times blank, and in the blank we're going to put our 3a. And then we can clean that up. 3a squared is going to be 9a squared. Remember that this exponent affects both of these. So we square the 3 and we get 9. We square the a and we get a squared. And we can have 3 times 3a gives us 9a. All right, there you have it. How about f of 3 plus a? Well, again, the function f is going to be x squared plus 3 times x. We got our blank squared plus 3 times blank. And now we're going to fill that blank, that empty space, with 3 plus a. So we're putting 3 plus a everywhere there's an x. Now we just got to clean it up. We remember that a plus b squared is a squared plus b squared, and in the middle, 2ab. Remember that? So we square the first, we get 9. Square the last thing, we get a squared. And we're going to multiply them, get 3a and double that. We're going to get 6a. If you want to write it out, you're welcome to. Distribute the 3 times 3 is 9. 3 times a is 3a. And now all we got left is combine like terms. So we've got a squared, and we've got 6a and 3a, that's 9a. And we've got 9 and 9, that's 18. And we got it. All right, so that's how we evaluate there. That's nothing terribly new there, but now we're going to talk about composite functions and see how this applies to something called composite functions, all right? So let's think about a situation here. I'm going to start a new coffee stand, and I'm going to call it Simply Lattes because I like lattes, and so that's all I'm going to serve. And so I'm going to charge $2.50 per latte, and my overhead I figured out is going to be $175 per day for my little stand and everything I need there. And each cup of coffee is going to cost me about 75 cents to make. All right, so I got all my numbers figured out here. And so my revenue is going to be 2.5 in, because it's 2.5 times 2, it's 250 times the number of lattes sold. So n is going to be the number of lattes sold. And my cost is going to be 75 cents per latte plus the $175 per day. All right, so now I got some functions based on how many lattes I sell. Well, after being open for a few months here, I've discovered that the number of lattes sold is a function of the high temperature of the day that we'll use T for. All right, so if I look up the temperature, I can figure out how many lattes I'm going to sell or get a pretty good idea. And after doing a little bit of regression, I figured out that, well, the number of lattes I'll sell is 240 minus 2T, where T is the temperature of the day, the high temperature. All right. So let's use that function to get a new function. I'd like to have a function for revenue and cost and profit based on T, temperature. So in terms of T, well, let's see. Let's think about our revenue. So our revenue as a function of temperature, well, it was 2.5 times N, but N is just this right here, 240 minus 2T. And if we clean that up, 2.5 times 240, that's 480, and 120, that's 600. And 2.5 times 2 is 5T. So there's my function for revenue as a function of T, the temperature. All right, well, what about the cost? So we can take my cost function, 75 cents times N plus 175, and let's make that in terms of T. So we're going to have 0.75 times N. Well, N is 240 minus 2T. And so cleaning that up, we distribute. And 3/4 of 240 is, let's see, 180. 60 times 3. And 0.75 times -2 would be -1.5, right? Like $1.50. Okay. So there's my cost function. All right. So now profit. Know that profit is going to be revenue minus the cost. All right. So profit is going to be my revenue minus my cost. So to get our profit function, we'll just put those two things together. So our revenue is 600 minus 5T minus 180. Let's put this in parentheses, 1.5T. All right. So we can clean that up a little bit. Let's distribute this negative here. That -1 is like -180 plus 1.5T, because we got minus -1.5. And cleaning that up, we get our profit function. 600 minus 180 gives us 380, 320, right? 320, there it is. And -1.5 plus 1.5, that's going to give us a -3.5T. All right, so now if I wake up in the morning and I get my weather app out and I figure out the temperature, the high temperature of the day, I can plug that into my new formulas, and I got a pretty good idea what my profit will be, my cost, and my revenue. So this is what we call a composite function, because we've taken this function n of t and plugged it in for n here. So we've put this one, this n of t, this whole function here, and dropped it in for n. That's what we call a composition. All right, so let's explore that a little bit more and see how we can make some composite functions. So a composition is written like this. A composition function of the composition of f with g, we write it like this. F, that little circle, means composed with g. And what this means is this is going to be f of g of x. We read it as f of g of x. In other words, we're putting g, the function g, into the function f. And there are some domain things. Okay, the domain of this new function, meaning the domain is the legal x values. Well, the x values have to be in the domain of g. In other words, they have to work for g. And then the g of x has to be in the domain of f. All right, so that's some side note there. All right, so what does this mean? So let's look at an example here where we have two functions. We have f of x, which is defined as 2x minus 5, and we have g of x, which is x squared plus 4. All right. So we want to find these compositions. All right. So this is read f composed with g of 2. So we're putting 2 into this composition function. Well, what does that mean? That means we're going to take, and we want f, we're going to take function f, and we're going to put g into f. So we can read this also as f of g of x, or f of g of x. Or in this case, not x, but f of g of 2. So we have a specific x value. It's 2 in this case. Well, what is g of 2? Well, let's go find that out. G of 2 is, now usually it's good to avoid side problems, but in this specific situation, let's go ahead and do these side problems. And we'll figure out that when we plug in 2, we get 2 squared plus 4. So we have 2 squared plus 4, which is 4 plus 4, which is 8. So we're going to take our f function, and we're going to put 8 in it, because g of 2 is 8. All right, well, what is our f function? The f function is right here, 2x minus 5. So we're going to take 2 times the input minus 5. What is the input? We're putting in 8. All right, and that gives us 2 times 8, which is 16, minus 5, which is 11. All right, so we found f composed with g of 2, meaning we put g of 2 into f. Well, what if we flip it around? What if we have g composed with f of 2? All right, so that means we're going to take the function g, and we're going to put f inside of g, and specifically f of 2. Well, what is f of 2? Well, let's go find out. F of 2, we're going to use our f function here, 2 times x minus 5, or 2 times the input minus 5, and the input in this case is 2. So this is 4 minus 5, which is negative 1. So we're going to take our g function, and we're putting negative 1 inside of that. And what do we get? Well, the g function is x squared plus 4. So we're taking the input, squared plus 4, which is 1 plus 4, which is 5. Okay? All right. So those are situations where we had a certain input. In this case, 2 was our input. Well, what if we want f composed with g of x? So this is going to give us kind of a generalized form, or generalized formula. So we're going to take function f. Let's first rewrite this, and we're putting in g of x into f. So this is f composed with g. In other words, g goes into f. And we're just keeping this general with the x right now. All right, well, what is function f? Function f says 2x minus 5. So function is 2 times the input minus 5. In this formula, x is the input. So this means 2 times whatever the input is minus 5. All right, that's what this tells us up here. Well, what is the input here? Well, the input is g of x. So we're going to take g of x, which is x squared plus 4, and we're going to put that into f. So g of x is x squared plus 4, so we're putting that into the f function. And now we can work that out. We can distribute 2 times x squared, 2 times 4, and clean it up. 8 minus 5 is 3. So we found that f of g of x is 2x squared plus 3. All right, so now if we were to plug 2 into here, by the way, you could test it out. 2 squared is 4 times 2 is 8 plus 3 is 11. All right, so this is now a formula that you could use for this. Okay? All right. Now, what about g composed with f of x? All right, so we have g of f of x. So the first thing we want to write is we want to rewrite this as g of f of x. So we're putting f inside of g. G of f of x. G of f of x. All right? This is not multiplication, right? We're composing. We're putting it inside the function. So we ask ourselves, what is the g function? The g function is the input squared. See, x is the input. So the input squared plus 4. So we have the input squared plus 4. Now we say, what are we putting into g of x? We're putting f of x into g of x. And what is f of x? It is 2x minus 5. So we're putting f into g. F into g. So here's what f of x is. We're putting it into the function g. All right. And so now we've got to square that function there. All right. So remember, your a plus b squared is a squared plus 2ab plus b squared. If you want to write this out, you can. 2x minus 5 times 2x minus 5. All right, but let's see. We've got 4x. So we're going to square the first thing, a squared, square the first thing. And so that's 4x squared. Square the last thing, that's negative 5. Negative 5 squared, that's our b squared. So that's plus 25. And in the middle is 2ab, 2 times their product. If we multiply these, we get negative 10x. Double negative 10x, we get negative 20x. Plus 4. So a little cleanup, 4x squared minus 20x plus 29. And there it is. That is a g of f of x. All right, so that's what a composition is, and that's how that works, all right? So one other way we can find compositions is this, if we have a table of values. And so if we have g of f of negative 3, well, first of all, it's best to rewrite this. So let's rewrite this as g of f of negative 3. That'll probably make more sense. We're asking ourselves, what is f of negative 3? Well, when x is negative 3, this table tells us that f of negative 3 is negative 4. So we don't have an equation, but we do have the table to tell us that. So g of, and we're going to put negative 4 into there. And then we say, well, what is g when x is negative 4? When negative 4 is the input. So when the negative 4 is the input, g of x is 15. All right. And this next one, let's change this example a little bit because the table actually doesn't work for negative 3. So a quick little fix there. Let's find f of g of negative 1. All right, we can do that. So we're going to take the function f and we're going to put to it g of negative 1. And we ask ourselves, what is g of negative 1? Well, when x is negative 1, g of negative 1 is 0. All right. So we're going to take, and we're going to rewrite this as f of, and instead of g of negative 1, we can put 0 in there. So now the question is, when 0 is the input, what is f? And the answer is 2. So this is 2. Okay, that's how it works with a table. All right, so we find, first rewrite it, and then we find the inside part first, and then finish it off. Same thing when we got equations. Rewrite it, find the inside part first, and then finish it off. If we have an x, we substitute the inside part and then simplify it to get our final expression.